Good evening, Seekers, and welcome back to the Sleep Scholar Archive. If this is your first night with us, then allow me to show you where you have arrived. This is a quiet place for restless minds, a place for those who wish to learn, but not be shouted at, a place for old questions, strange histories, distant worlds, forgotten books, and the deep mysteries that human beings have carried with them since the first night someone looked upward and wondered what the stars were trying to say. Here, each journey is kept as a book. Each book opens a different wing of the archive, and each chapter is written to be entered slowly, not as a lecture, not as a demand, but as a long candlelit passage through knowledge, meant to accompany you into sleep. Our first book led us through lost books of magic, ancient alchemy, grimoires, occult history, and the endless human hunger for hidden knowledge. But now, the archive has opened another door. A door of glass, brass, shadow, starlight, and silence. Tonight, we continue Book 2, the Book of the Cosmos. In the first chapter, the Observatory opened. We sat in the quiet chamber of the archive's old starship, surrounded by shelves of worn books, ticking instruments, sleeping lamps, and the soft hum of a vessel moving through the dark. Beyond the great window, the stars waited. We left Earth behind, not in fear, not in escape, but in wonder. We looked back at the blue world that made us, and we saw how small it was. We passed the moon, that pale companion that has watched our tides, our myths, our calendars, and our lonely nights. We turned toward the sun, the ancient fire at the center of our days, and remembered that every garden, every ocean breeze, every meal, every breath of warmth on human skin is borrowed light. We drifted past the planets, each one strange in its own way. Mercury, scorched and silent. Venus, bright and poisonous. Mars, cold and red. Jupiter, vast and storm-crowned. Saturn, ringed like a dream. Uranus and Neptune, blue and distant, turning slowly in the outer cold. And then we went farther, past the familiar roads of the solar system, past the old maps of human comfort, into the fields of stars. We spoke of distance, of light years, of ancient light arriving long after its source has changed, faded, or died. We spoke of the Milky Way, not as a decoration in the sky, but as a great city of stars, so vast that our entire solar system is only one quiet room within it. And at the end of that first night, we stopped. Because some doors should not be rushed through. The observatory was open, the book was before us, and the cosmos had only just begun to speak. Tonight, we turn the page. And this time, Seekers, we are not simply looking outward, we are looking backward. Backward through distance, backward through light, backward through the memory of the universe itself. Because when we look deeply enough into space, we are not only seeing faraway places, we are seeing old places, ancient places, versions of the universe that no longer exist in the way their light first left them. A star seen from 10 light-years away is not seen as it is tonight, but as it was 10 years ago. A galaxy seen from 1 million light-years away is not seen as it is now, but as it was before many human stories ever began. And if we look far enough, with instruments more patient than any human eye, we begin to see the universe not as it is, but as it was when it was young. Tonight's chapter is called The First Light, and it is the beginning behind all beginnings. Before the stars, before the galaxies, before planets, moons, oceans, forests, books, temples, names, hands, memory, or breath. Before there was anyone to ask where we came from. Before there was even a night sky to look into. Tonight, we move toward the earliest glow the universe has left for us. Not the first moment itself, that remains hidden behind a veil we cannot yet fully lift, but the first light we can still read, the oldest visible message, a faint warmth stretched across all of space, a whisper from the childhood of everything. So settle in, let your breathing slow, let the room around you become quiet, let the soft lamps of the observatory burn low. The chair by the window is waiting, the instruments are still. The stars outside are no longer only destinations, they are markers in time, and tonight we follow them backward, past the age of galaxies, past the age of stars, past the dark before starlight, toward the hot, bright, hidden beginning of all things. The archive is open, the vessel is quiet, and the first light is waiting. First light, we must begin with a mistake. A very natural mistake. When most people hear the words Big Bang, they imagine an explosion, a point in empty darkness, a sudden burst, matter flying outward like sparks from a fire. But that is not quite what the universe seems to have done. The Big Bang was not an explosion inside space. It was the beginning of space as we know it. There was no empty room waiting for the universe to appear, no outside darkness, no great black stage with a burst of fire at the center. Space itself was changing. Space itself was stretching. The distances between things were growing, not because everything was flying through an empty void, but because the fabric of the universe was expanding. This is strange. It should feel strange. The beginning of the universe is not something the human mind can picture easily. Our minds understand rooms, fields, roads, oceans, skies, places where something can happen. But here, we are speaking about the origin of the place where all places would someday exist. The beginning of distance, the beginning of the stage, the beginning of there being a far away at all. Imagine the great window of the observatory. Outside it, the stars drift in silence. Now imagine that we could reverse the motion of time. Galaxies draw closer, clusters fold inward. The cosmic web tightens. The Milky Way and Andromeda are no longer separated by millions of light years. Stars disappear back into the gas that made them. Planets unmake themselves. Dust returns to fire. Fire returns to something even simpler. Everything becomes hotter. Everything becomes denser. Everything becomes younger. If we continue backward, the universe does not become a single object sitting somewhere. It becomes a condition, a state, a universe where every region of space was once much closer to every other region. A universe so hot that familiar structures could not yet exist. No stars, no atoms, no planets, no chemistry, no stone, no water, no bodies, no eyes to see, only energy, pressure, heat, and possibility. This is the first doorway we pass through tonight. The universe was once small, but not small like a marble on a table. That image still gives the table too much importance. It was small because all measurable distances were compressed. Everything that would become the observable universe was once gathered into a hotter, denser state. The space between future galaxies had not yet opened. The silence between future stars had not yet arrived. Even darkness, as we know it, had not yet learned how to be dark. And as we move closer to the beginning, language begins to weaken. Science can take us very far. It can trace the universe back billions of years. It can read ancient light. It can measure the afterglow of a time before stars. But the first instant remains difficult. The closer we get to the beginning, the more extreme everything becomes. temperatures beyond ordinary imagination, density beyond ordinary matter, conditions where our familiar laws of physics begin to blur into deeper questions. So tonight, we will not pretend to stand outside the beginning and look at it like a painting. We cannot do that. No one can. Instead, we will follow the evidence as far as the light allows. We will watch the universe expand. We will watch it cool. We will watch it become clear enough for light to travel freely. And when that light finally escapes, it will begin a journey that still continues all around us. That ancient glow is what we call the first light. But before that light could travel, the cosmos was still a furnace, too hot for atoms, too bright to be seen, too young for stars. A beginning filled with everything that would someday become something else. So rest here for a moment. Let the thought be large without needing to be solved. The universe was not born into space. Space was born with the universe. And from that first expansion, every future distance began. Every future night, every future star, every future world, even the quiet room around you now, even the breath moving slowly through your body. All of it belongs to the same unfolding. All of it began in that ancient fire. Section 3. In the earliest moments, the universe was not quiet. It was not dark. It was not filled with stars, or dust, or drifting worlds. It was hot beyond imagination, dense beyond ordinary meaning. A sea of energy so extreme that the familiar forms of matter could not yet settle into place. The universe was expanding, and as it expanded, it cooled. This is one of the great patterns of cosmic history. Expansion brings cooling. Cooling allows structure. Structure allows complexity. Complexity, given enough time, allows stars, planets, oceans, chemistry, memory, and eventually minds capable of asking how it all began. But at first, there was no complexity, only the beginning of possibility. In those first tiny fractions of a second, the universe changed with a speed that almost refuses to become real inside the imagination. Events happened faster than any heartbeat, faster than any blink, faster than thought. The cosmos was young in a way no living thing has ever been young. It had not yet learned patience. It had not yet opened into silence. Everything was too close, too hot, too energetic. Particles appeared and vanished. Forces that now seem separate may once have been joined in ways we still do not fully understand. This is one of the places where the archive grows especially quiet. Because honest wonder does not pretend to know what it does not know. Science can follow the universe back with astonishing power. It can measure ancient light. It can test predictions. It can listen to particles and radiation and the shape of space itself. But the earliest moments remain partly veiled, not empty of knowledge, but not fully opened. The beginning still keeps some of its doors closed, and perhaps that is fitting. A universe this old should be allowed a few secrets. As time moved forward, even by the smallest measure, the universe continued to expand and cool. Energy began taking forms. Particles became more stable. The wildness of the first instance softened into something that could begin to have a history. Not a history of people, not even a history of stars. A history of matter learning how to remain. Imagine heat so intense that atoms cannot exist. Not because the ingredients are missing, but because nothing can hold together. Every attempt at structure is immediately broken apart. Everything is collision. Everything is motion. Everything is too alive with energy to become still. This was the young universe, a place where the future was present only as a promise. The atoms in your body were not yet atoms. The calcium in bones, the oxygen in breath, the carbon in skin, the iron in blood. None of it had taken the forms we know. Those elements would require stars, and stars had not yet been born. At this stage, the universe was preparing the simplest foundations, the first ingredients, the first conditions, the first quiet rules that would allow later wonders to appear. There is something beautiful about that. Even the most magnificent things begin with conditions no one would call magnificent at the time. A forest begins as seed and soil. A song begins as silence and breath. A life begins before memory. And the universe began not with galaxies already shining, but with heat, expansion, and the slow permission for matter to become itself. Outside the observatory window, the stars still appear calm. They shine as though they have always been there. But tonight we know better. There was an age before every star, an age before every sunrise, an age before light could travel freely across the dark. We are moving toward that age now. Not with engines, not with speed, but with thought, with evidence, with the strange gift of looking far enough into space that distance becomes time. The farther back we travel, the simpler the universe becomes, the grand structures fall away, galaxies vanish, stars vanish, atoms themselves wait beyond the next door. And still the universe continues expanding. Still it cools. Still it prepares, without intention, for everything that will one day arrive. The first light is not here yet. Not quite. Before light could cross the universe freely, the universe had to change. It had to cool enough for matter to become transparent. It had to pass from a glowing fog into something light could finally escape. And so, we continue backward in our understanding, and forward in the universe's story. Toward the first atoms, toward the first clear passage, toward the moment when the cosmos became visible to itself. Section 4. As the universe cooled, the first lasting ingredients began to appear. Not stars, not planets, not atoms yet. Something simpler. Particles that would one day become the centers of atoms. Protons, neutrons, tiny pieces of matter, formed in conditions so hot and dense that no ordinary image can hold them clearly. It may help to imagine the young universe not as a place filled with objects, but as a blazing ocean where everything was still being decided. Matter was not yet arranged into the familiar world. There were no solid things, no surfaces, no shadows, no quiet distances, only heat, motion, collision, and change. And yet, even in that wild beginning, the future was quietly taking shape. The universe was learning how to keep some of what it made. At first, particles appeared and disappeared constantly. Energy became matter. Matter became energy. The boundary between the two was not as firm as it seems in ordinary life. Everything was too hot for stability. But expansion continued. And with expansion came cooling. With cooling came the possibility that some particles might remain. Slowly, the universe became a little less violent. Not calm, not yet, but less impossible. Protons and neutrons began to survive. And soon, in the first few minutes, they began joining together. This was not chemistry. Chemistry would come much later, after atoms existed. This was something older. A first kind of cosmic making. The earliest nuclei formed, mostly hydrogen, some helium, a very small amount of lithium. Simple beginnings, almost painfully simple, compared with the richness of the universe we know. No carbon yet, no oxygen, no iron, No gold, no calcium. None of the elements that would later form mountains, blood, oceans, trees, paper, ink, or human hands. Those heavier elements would have to wait. They would be forged later inside stars, and in the depths of stars. But in these first minutes, the universe made the lightest foundations. Hydrogen, helium, a trace of lithium. The plainest alphabet from which later chapters would be written. There is something beautiful about how little the universe began with. We often imagine creation as something grand from the start. Already complex, already full, already shaped into worlds. But the early universe teaches a quieter lesson. Great things do not need to begin fully formed. Sometimes they begin almost empty of detail. A few simple ingredients, a few deep laws, a little time, and patience beyond anything human beings can easily imagine. From hydrogen would come stars. From stars would come heavier elements. From those elements would come planets. From planets would come oceans. From oceans, perhaps life. From life, memory. And from memory, a voice in the dark asking where it all began. But at this moment in the story, none of that had happened. The universe was still very young, only minutes old, and already the first ingredients of everything were being prepared. The universe was still too hot for atoms to hold together. Electrons could not yet settle into place. The cosmos was filled with a glowing plasma. A thick, bright fog of charged particles and light. Photons tried to travel, but they could not go far. Again and again they struck free electrons. Again and again they were scattered. The universe was bright, but not transparent. Filled with light, but impossible to see through. This is a strange thought. There was a time when the universe contained light everywhere, yet no clear view of anything. A glowing fog without windows, a brightness without stars, a cosmos not dark, but hidden. For the first light to reach us, something had to change. The universe had to cool enough for electrons to settle around nuclei. It had to allow atoms to form. And once atoms formed, light would finally be released from the fog. It would begin to travel freely, across expanding space, across billions of years, toward instruments, telescopes, and quiet minds waiting in the dark. But that moment has not arrived yet. For now, the universe is still young, still hot, still bright, still unable to show its own face. The first ingredients have appeared, the first nuclei have formed. The first future stars have received their raw material. And the first light waits just beyond the veil. Section 5. For a long time, the young universe remained hidden inside its own brightness. Light existed everywhere, but it could not travel freely. It was trapped inside a glowing fog of charged particles. Photons moved, but only for a moment. Again and again, they struck free electrons. Again and again, they scattered in new directions. The universe was filled with light, yet no light could cross it clearly. It was not dark, it was not empty, it was brightness without a window. A dawn that had not yet opened. For hundreds of thousands of years, the universe continued to expand, and as it expanded, it cooled. Slowly, the violence softened. The first nuclei were already waiting. Hydrogen, helium, a trace of lithium. But they were not yet full atoms. Electrons still moved freely through the hot plasma, too energetic to settle into place. Then, at last, the universe cooled enough for something extraordinary to happen. Electrons began to join with nuclei. Hydrogen atoms formed, helium atoms formed. Matter became neutral. The fog began to clear. This moment is sometimes called recombination. a quiet word for an enormous change. It does not mean the universe became finished. It means light was finally free. The photons that had been trapped in the bright fog could now travel across space without constantly striking charged particles. For the first time, the universe became transparent. A window opened everywhere at once, and light began its long journey. Not from one lamp, not from one star, not from one place in the dark, from every direction, from the whole young universe. The first light was released like a memory that had been waiting since the beginning. Imagine the observatory growing still around you. The fire lowers. The instruments turn towards something older than any star. Beyond the window, the galaxies fade from thought. The stars fade. The familiar night sky disappears. We are looking toward a time before constellations, before suns, before worlds, before the universe had learned its visible shape. And there, stretched across all of space, is the first light we can still read. It is faint now, almost impossibly faint. The universe has expanded for billions of years since that light began traveling. As space stretched, the light stretched with it. What began as a hot glow became cooler. Its wavelengths lengthened, its brightness softened. Today, it no longer appears as visible light to our eyes. It has become a gentle microwave glow, arriving from every direction in the sky. Scientists call it the cosmic microwave background, but names can make wonders sound smaller than they are. This is the oldest light we can observe. A portrait of the universe when it was still young. A message from before the first stars. A photograph taken by nature itself, long before there were eyes to see it. When astronomers study it, they are not looking at one object. They are looking at the early universe surrounding us in every direction. Behind the stars, behind the galaxies, behind every later chapter of cosmic history. The first light remains. Soft, faint, patient, still arriving. And hidden within that ancient glow are tiny differences. Small variations in warmth and density. Almost nothing. And yet from those almost nothings, gravity would begin its patient work. A slightly denser place could pull in more matter. A small difference could grow. A whisper could become a structure. A seed could become a galaxy. This is how gently the universe sometimes begins its greatest works. Not with perfection, but with unevenness. Not with a finished design, but with the faintest difference. For now, rest with that image. The universe has cleared. Light has escaped. The first great window has opened. And across the newly transparent cosmos, the oldest glow begins traveling toward every future eye that will one day learn how to see it. Section 6. After the first light was released, the universe entered a strange and quiet age. The fog had cleared. The photons were free. The oldest light had begun its long journey across expanding space. And yet, there were still no stars, no galaxies, no planets, no moons, no shining cities of suns. The universe had become transparent, but it had not yet become luminous in the way we know it now. This age is sometimes called the Cosmic Dark Ages. The name sounds almost frightening. But there was nothing evil in that darkness. It was simply an unfinished darkness, a waiting darkness. A universe filled mostly with hydrogen and helium, spreading slowly outward, cooling and carrying within it the faint unevenness left behind in the first light. Those tiny differences mattered. A place with slightly more matter than its surroundings had slightly more gravity. And gravity, patient as ever, began to work. It did not hurry. It did not announce itself, it simply pulled. A little more matter gathered, then a little more. The dense places became denser, the empty places became emptier. Across vast stretches of time, the smooth young universe began to gather into shape. Not quickly, not dramatically, but steadily. Like dust settling into hidden patterns. Like a thought forming in a quiet mind. Like a story beginning before anyone knows what it will become. The first light showed the universe as it was when it became transparent. But the Dark Ages were the long pause after that first opening. The page had been revealed, but the ink had not yet appeared. There is something deeply beautiful about this. Even after the first light, the universe still needed darkness. Before stars could burn, matter had to gather. Before galaxies could turn, gravity had to build. Before the night sky could shine, the cosmos had to wait. We often think of darkness as the opposite of creation, but sometimes darkness is where creation prepares itself. A seed waits underground, a child grows unseen, a song gathers before it is sung, a thought forms before it becomes words. And in the early universe, the first stars gathered inside darkness long before their light ever touched the sky. Outside the observatory window, we are used to seeing stars. Their presence feels natural, as though the universe should always have had lights scattered through it. But there was an age when the cosmos had no stars at all. An age when there was matter, gravity, time, and the faint memory of light. That was enough. Slowly, great clouds of hydrogen and helium began to collect. They were not clouds like those above Earth. They were enormous regions of gas, stretching across distances that would swallow imagination. Within them, gravity pressed inward. The gas grew denser, the centers grew hotter. For a long time, nothing visible happened. Only gathering, only pressure, only the quiet strengthening of a hidden fire. Then, somewhere in the dark, the first stars began to approach their birth. Not all at once, not everywhere, but in scattered places, where gravity had gathered enough matter to begin something new. The universe was preparing to light its first lamps. These first stars would be unlike the quiet stars we know today. They were born from simpler ingredients, almost only hydrogen and helium. They may have been enormous, brilliant, short-lived. They burned fiercely, spent themselves quickly, and changed the universe forever. But we are not quite ready to enter their fire. That belongs to the next chapter. For now, we remain in the pause before starlight, the age after the first light, but before the first stars, a silence between two awakenings. The universe had become transparent. The oldest glow was traveling. Gravity was gathering matter. And in the deep dark, the first structures were beginning to dream themselves into being. The archive grows still as we pass through this thought. The fire beside us burns softly. The instruments hum. Outside the great window, the stars shine as they do now. But tonight we remember that they were not always there. Once, the universe waited for them. Once, the darkness was real. And within that darkness, the future was already gathering. Section 7. The first light did not vanish when it began to travel. It changed, it stretched, it cooled, but it remained. For billions of years, that ancient glow moved through the expanding universe, becoming softer with every passing age. What began as a hot, bright release became something nearly invisible. Not gone, only transformed. The universe had carried it patiently, like an old memory folded into the background of everything. Long after the first stars were born, it remained. Long after galaxies gathered into spirals and clusters, it remained. Long after planets formed around young suns, it remained. And when Earth finally cooled beneath its own sky, when oceans gathered, when life began, when creatures opened eyes for the first time, it was still there, arriving from every direction, quietly, constantly, a glow older than every star in the night sky. For most of human history, no one knew it existed. People watched the moon. They named constellations. They followed planets. They built myths, calendars, observatories, and maps. But behind everything they saw, behind every familiar light, the first light was still waiting. It could not be seen by ordinary eyes. It was too stretched, too cooled, too faint. It had become a soft microwave whisper, hidden beneath the visible sky. The universe was speaking in a language we had not yet learned to hear. This is one of the great lessons of the cosmos. Reality does not disappear simply because we lack the senses to notice it. There are colors the eye cannot see, sounds the ear cannot hear, forces the hand cannot feel, histories too old for memory, truths too quiet for ordinary attention. The archive knows this well. Many of its oldest books were not found because someone already understood them. They were found because someone listened differently. So it was with the first light. Humanity had to build new instruments, not eyes exactly, but listeners. Machines sensitive enough to detect a faint signal coming from the deep background of the sky. And when that signal was finally noticed, it did not arrive like thunder. It arrived like static. A persistent noise, a soft hiss, something that seemed, at first, like an inconvenience. Imagine that for a moment. One of the oldest messages in the universe did not announce itself with majesty. It did not arrive carved in gold. It did not speak in words. It appeared as a stubborn background sound that would not go away. No matter where the instrument turned, the whisper remained. North, south, high above, low on the horizon, every direction carried it. The signal was not coming from a star, not from a galaxy, not from Earth. It was coming from everywhere, from the universe itself. The first light had been found, not bright to the eye, not dramatic to the senses, but profound beyond measure. A remnant of the time when the universe first became transparent. An afterglow from before the first stars. A fossil made not of bone or stone, but of light. There is something almost humorous in the humility of it. The universe handed us one of its greatest clues as background noise, as if to remind us that wonder is not always loud. Sometimes the most important truth in the room is the quietest one. Sometimes revelation does not interrupt. It waits. It hums softly behind everything else until someone becomes patient enough to notice. Now, here in the observatory, the instruments turn toward that ancient glow. Their brass rings shift slowly. Their glass faces catch the firelight. Their needles tremble, not toward a single star, not toward a single place, but toward all directions at once. Because the first light surrounds us. It is not ahead of us. It is not behind us. It is everywhere the sky is deep enough. Wherever we look, we are looking back toward it. The great window of the observatory seems darker now, but the darkness has changed. It is no longer simply the space between stars. It is a veil in front of an older radiance, behind the galaxies, behind the constellations, behind the long familiar theater of night. There waits the childhood image of the universe, soft, cold, stretched almost beyond recognition, but still present, still readable, still carrying the faint pattern of what everything would become. And as we sit quietly with that thought, the archive seems to breathe a little more slowly. The first light is not lost. It has been traveling toward us all along. Section 8. The first light is not perfectly smooth. If it were, the universe would have become something very different. A perfectly even universe would have had no preferred places, no denser regions, no hidden seeds, no small beginnings for gravity to gather. Everything would have remained too balanced, too equal, too still, but the ancient glow carries tiny differences. Small variations in temperature, small variations in density, places only slightly warmer, places only slightly cooler, almost nothing. And yet almost nothing can matter enormously when time is patient enough. These tiny differences were the first clues of future structure. The earliest hints that the universe would not remain smooth forever. Gravity could begin to favor the denser places. Matter could gather there a little more easily. And as matter gathered, gravity grew stronger. Then more matter gathered, and gravity grew stronger still. This quiet process would eventually build everything large. Galaxies, clusters of galaxies, long filaments of matter stretching across the universe like glowing threads, great dark spaces between them. The cosmic web, but in the first light, all of that was only a suggestion, a faint pattern, a whisper in the glow. It is strange to think that the grand architecture of the universe began as such delicate unevenness. The Milky Way, Andromeda, the galaxies beyond them, the future stars, the future worlds, the future Earth. All of them depended on the universe not being perfectly smooth. Perfection, in this case, would have been emptiness of possibility. It was the flaw that allowed creation to continue. The archive has always understood this in its own way. A perfectly blank page contains no story. A perfectly still room contains no song. A perfectly even field gives no river a path to follow. It is the difference that begins the movement. The mark on the page, the breath before the voice, the slight leaning of matter toward matter. When astronomers study the first light, they are studying those first differences. They are looking at the universe when it was still young enough to carry its childhood on its face. Not a face of stars, not a face of planets, a face of temperature, a face of faint variations. A map written before maps existed. And from that map, we learn something extraordinary. The universe was already carrying the seeds of everything it would become. Not in detail, not as destiny, not as a finished plan, but as possibility. The first light did not contain a picture of Earth. It did not contain oceans, forests, books, or human names. But it carried the conditions from which such things might one day emerge. A slightly denser region here, a slightly cooler region there, a little more matter, a little more pull. A beginning small enough to be missed by anything less patient than science. Outside the observatory window, the stars shine with calm certainty. But now, behind them, we can imagine that older pattern. The faint background glow, the tiny unevenness, the first soft texture of the visible universe. It is easy to feel small beneath such thoughts. But perhaps smallness is not the same as meaninglessness. Perhaps we are small in the way a letter is small, one mark among many. But without small marks, no book can be written. The universe is vast, yes, but vastness is made of details. A galaxy is made of stars. A star is made of particles. A body is made of cells. A life is made of moments. And the largest structures in the cosmos began with variations so tiny they would seem almost impossible to notice. So if tonight you feel unfinished, uncertain, or small within the scale of things, remember this. The universe did not begin with finished forms. It began with heat, expansion, light, and faint differences waiting for time to reveal what they could become. The first light is not only a relic, it is a promise kept across billions of years. A reminder that what begins subtly may still become immense. A reminder that the quietest pattern may one day hold galaxies. The instruments of the observatory continue listening. Their needles tremble in the amber dark. And somewhere behind every star outside the window, the first light remains. Not smooth, not perfect, alive with the small differences that gave the universe its future. Section 9. From the tiny unevenness in the first light, gravity began its patient work. It did not rush. It did not announce itself. It simply noticed where matter was gathered a little more thickly. A slightly denser region pulled more strongly than the space around it. That extra pull gathered more matter. And the more matter gathered, the stronger the pull became. In this way, the universe began to grow structure from almost nothing. Not from nothing completely, but from the faintest differences. A little more here, a little less there. A quiet imbalance, a beginning. Over immense stretches of time, those small differences deepened. Gas drifted toward denser regions. Matter collected into vast clouds. Invisible threads began to form across the expanding universe. The cosmos was not becoming a random field of scattered things. It was becoming a web, a great structure of matter and emptiness, filaments, knots, voids, long rivers of material flowing toward places where gravity was strongest. In time, the densest knots would become the cradles of galaxies. The emptier regions would become cosmic voids, enormous dark spaces where relatively little matter gathered. And between them, stretching across unimaginable distances, the universe would form a kind of architecture, not built by hands, not planned by a mind, but shaped by gravity, time, expansion, and the faint pattern left behind in the first light. This is one of the quiet miracles of cosmic history. The universe did not need to become beautiful. It could have remained simple, smooth, featureless, but it did not. It became textured, layered, structured. It became a place where matter could gather, ignite, collapse, orbit, cool, and become strange. A place where stars could burn. A place where galaxies could turn. A place where worlds could form around distant suns. A place where, much later, a small planet could grow oceans beneath a yellow star. The first light does not show us those later wonders directly. It shows us their earliest hints. The first sketch beneath the painting. The first notes before the song. The first hidden structure beneath the dream. Here in the observatory, the instruments translate that ancient light into patterns. A map of tiny differences. A portrait of the universe before stars. To human eyes it might not seem dramatic. No shining galaxies, no spiral arms, no planets, no nebulae glowing in magnificent color. Only subtle warmth. Almost even, almost smooth, but not quite. And that not quite is everything. The archive is filled with books that began the same way. Not with certainty, not with thunder, but with a slight disturbance in silence. A question written in the margin. A symbol no one understood. A fragment preserved when everything else was lost. Small things can carry enormous futures. A seed does not look like a forest. A spark does not look like a sun. A single line does not look like a finished book, and yet the future often hides itself inside forms too small to impress us at first. So, it was with the universe. The first galaxies did not appear suddenly from an empty dark. They grew from differences already present in the earliest light. Gravity followed those differences. Matter answered gravity, and time, patient beyond measure, allowed the answer to become large. Outside the window, the Milky Way still shines in the present night. But now we can imagine it differently. Not as something separate from the beginning, not as a later decoration, but as a descendant of those first tiny variations. A vast river of stars whose possibility was already whispered in the oldest glow. The same is true of every galaxy beyond it, every cluster, every distant island of light. All of them began as small preferences in the young universe. Places where matter leaned slightly toward itself. Places where gravity found something to hold. The first light, then, is not only a memory, it is a map of becoming. It shows us the universe at the moment when the future was still faint, still hidden, still almost invisible, but already present enough for gravity to begin reading it. And perhaps that is why this ancient glow feels so strangely intimate. It does not simply tell us where the universe was. It tells us how the universe became capable of change, how a nearly smooth beginning could become a sky filled with stars, how almost nothing, given time, could become everything we know. Section 10. The first light also teaches us that the universe has not remained still. It has been stretching, expanding, carrying ancient light with it. When that light first began traveling, the universe was much hotter than it is now. The glow was bright, dense, filled with energy. But as space expanded, the light traveling through it was stretched as well. Its waves grew longer. Its color changed beyond the range of human sight. What was once a hot visible glow became a cooler microwave whisper. Not because the light became tired, not because it lost its way, but because the space through which it traveled continued to grow. This is one of the strangest and most beautiful ideas in all of astronomy. Light does not merely move through the universe. It is shaped by the universe. It carries the history of the space it has crossed. A beam of ancient light is not only a messenger from the past, it is also a witness to expansion. The first light has been stretched across billions of years, softened from fire into faint warmth, until it became the quiet background glow we can detect today. The observatory instruments read this ancient stretching. They do not hear words. They do not see pictures in the ordinary sense. They measure patterns, temperatures, frequencies, tiny differences. The faint signature of a universe that was once hotter, denser, and younger. This is why the first light matters so deeply. It is not merely beautiful. It is evidence. A relic that confirms the universe was once in a very different state. Not eternal and unchanging, not fixed forever in its present form, but evolving, cooling, expanding, becoming. The cosmos we see now is not the cosmos as it has always been. The night sky is a later chapter. The stars are later chapters. The galaxies are later chapters. Even darkness, as we know it, is a later chapter. Before all of them, there was the glow. And before the glow could travel freely, there was the furnace. In this way, the first light becomes a bridge. It connects the universe we can see to the universe we can only infer. It does not show us the first instant. That remains hidden. but it brings us closer than ordinary imagination ever could. It lets us stand, not at the beginning itself, but near the earliest visible page. A page written when the universe was only a few 100,000 years old. That may sound ancient, and to any human life, it is. But to the universe, it was infancy. The cosmos is now billions of years old. To see it at a few 100,000 years old is to see something astonishingly young. You might imagine finding a photograph of an old forest when it was still a field of seedlings, or hearing the first notes of a song whose final movement is still being played. The first light is the universe in its childhood, not silent, not empty, not yet filled with stars, but already carrying the pattern of everything to come. The thought is difficult to hold, and that is all right. The archive does not ask you to master it tonight. It asks only that you rest beside it for a while. Let the idea drift gently through the room. Light stretched by space, time written into color, the past arriving from every direction. A universe that remembers being young. Outside the window, the stars still shine with familiar calm. Yet now they seem layered. In front of them is the present sky. Behind them is the ancient glow. And behind that glow lies a beginning we can approach only through mathematics, evidence, and wonder. This is how far the book has opened. From the quiet chair in the observatory, we have followed light backward past stars, past galaxies, past the first clear view of the universe itself. And still the story continues. Because once the first light was free, once the universe became transparent, once the faint seeds of structure had been left behind, time began to deepen the pattern. Gravity continued ridding the ancient unevenness. Matter continued gathering in the dark. The first stars were still waiting. The first galaxies had not yet turned. But the path toward them had been set. The universe had become visible. Now it had to become luminous. Section 11. The universe had become visible, but visibility is not the same as light-filled beauty. The first light was free, yes. It could travel. It could cross the expanding dark. It could carry with it the faint pattern of the early cosmos. But after that release, the universe did not immediately become the shining place we imagine when we look into the night sky. There were no stars yet, no galaxies bright with spiral arms, no nebulae glowing in red and blue, no planets circling young suns. The first light had opened the window, but the room beyond it was still waiting to be furnished. For a long age, the universe was simple. Vast clouds of hydrogen and helium drifted through the dark. Gravity continued its patient work. Matter slowly gathered where the first light had shown the earliest slight differences. The denser places became denser, the thinner places became thinner. The universe was no longer a smooth young glow. It was beginning to form hidden structure. But to an eye, if any eye could have existed then, there would have been very little to see. Only darkness, not the darkness of emptiness. The darkness of preparation. The darkness of something gathering itself before becoming visible. Here, the archive grows quiet, because this part of the story feels strangely familiar. So many things in life begin this way. Not with announcement, not with proof, not with an audience, but in a hidden season where almost nothing appears to be happening. A person changes before anyone notices. A wound heals below the surface. A thought matures in silence. A future life gathers itself through small choices no one sees. The early universe knew such a season. It had released its first light. But the first stars had not yet come. It had become transparent, but not yet luminous. It had become readable, but not yet radiant. This is why the first light is so important. It is the last glow before the long dark age. A record of the universe just before gravity began shaping it into the structures that would one day fill the sky. If we could hold that ancient light like a page, we would be holding the universe before it had learned to shine with stars. A universe young enough to be simple, old enough to remember its beginning, and patient enough to become everything else. Outside the observatory window, the familiar stars seem almost impossible now. Each one is a later answer to a question that began in the first light. Each one is a flame gravity eventually learned how to kindle. Each one is part of a story that passed through darkness first. The sun itself, so ordinary and so necessary, belongs to that story. It did not exist in the early universe. The Earth did not exist. The atoms that would become our oceans and bones had not yet been made. Even the elements required for stone, blood, and breath were waiting for future stars to forge them. And yet, in the first light, the conditions for those future stars were already present. Not fully, not visibly, but in outline, in pattern, in the faint unevenness of matter. In the soft variations gravity would follow. The universe was carrying its future quietly. That may be one of the gentlest truths this chapter offers. The future does not always appear as a clear image. Sometimes it appears as a difference too small to understand. A slight pull, a faint pattern, a nearly invisible beginning. The first light did not look like galaxies. It did not look like stars. It did not look like Earth. It looked like a soft ancient glow with tiny variations almost too subtle to imagine. And yet, that was enough. Enough for gravity. Enough for time. Enough for the long work of becoming. The instruments in the observatory continue to listen. Their needles tremble softly. Their glass faces reflect the amber lamps. They are not merely measuring old radiation. They are reading the childhood of the cosmos. They are reading the moment when light first became free, and the universe first became visible to itself. A strange phrase. Visible to itself. There were no eyes yet, of course. No observers, no minds, no witnesses. But the light existed. The pattern existed. The record existed. The universe had made something that could one day be seen. Long before there were beings capable of looking, the universe had already prepared a memory for them. And billions of years later, on a small blue planet around an ordinary star, those beings would build instruments delicate enough to find it. The first light had waited all that time. Not impatiently, not intentionally, simply traveling, simply remaining, simply carrying the old pattern forward. And now, here in the quiet of the archive, we understand something that no ancient skywatcher could have known. Behind every star they named, behind every constellation they imagined, behind every myth written across the heavens, there was an older. Section 12. The first light gives us a rare gift. It allows us to see the universe before it had become familiar, before the sky had stars, before galaxies had names, before any world carried oceans, mountains, storms, forests, or life. It shows us a universe that was still almost simple, almost smooth, almost without shape, but not quite. And in that, not quite, everything waited. This is difficult to understand because we live in a universe that feels full. Everywhere we look, there is complexity. Clouds fold over cities. Leaves turn sunlight into sugar. Oceans move under the pull of the moon. Human beings build languages, machines, cathedrals, songs, and stories. Even a single hand contains more organization than the early universe revealed to the eye. And yet, all of this richness had to come from a beginning far simpler than anything around us now. That is one of the quiet miracles of time. Given enough of it, simple things can become astonishing. Hydrogen can become stars. Stars can become furnaces. Furnaces can make heavier elements. Heavier elements can become stone, water, air, and living bodies. And living bodies can become conscious enough to ask where the hydrogen came from. The universe is not only a place, it is a process, a long unfolding. A transformation that began in heat and expansion, then moved through light, darkness, gravity, stars, and worlds. Tonight, we are still near the earliest pages. We have not yet reached the birth of stars. We have not yet entered the great stellar nurseries. We have not yet watched the first heavy elements being made. Those things wait in the next chapter. But already, the path has been prepared. The first light carries the earliest pattern. The Dark Ages give gravity time to read it. Matter begins to gather. The future begins to lean toward form. Outside the observatory window, every star appears calm, almost eternal. But no star is eternal. Each one belongs to history. Each one was born. Each one changes. Each one will someday end. The first light reminds us that even the stars are not the beginning. They are children of a deeper age, descendants of a universe that once had no lamps at all. This thought can make the night sky feel even more beautiful, not less. The stars are not simple decorations. They are later chapters of a story, already billions of years in motion. Every point of light is part of an inheritance. Every glow has an ancestry. Every sun is connected, however distantly, to the first fire. The archive is quiet now. The lamps are low. The instruments continue their patient listening. And perhaps for a moment, you can imagine the first light, not as a scientific diagram, not as a chart, not as data on a screen, but as an ancient veil surrounding everything. A soft glow from before the first sunrise. A remnant of a universe that had finally become transparent. A memory spread across the sky so completely that it is easy to miss. That may be the strange beauty of the oldest things. They do not always stand before us like monuments. Sometimes they surround us. They become the background. They become the silence behind the song. They become so constant that only careful attention reveals them. The first light is like that. It is everywhere. Behind every direction we look. Behind the present sky, behind the stars, behind the galaxies. A faint afterglow from the moment the universe first allowed light to travel freely. And because it remains, we are not cut off from the beginning. We cannot touch it. We cannot stand inside it. We cannot see the first instant itself, but we are not completely separated from it. Some part of that ancient beginning is still arriving, still measurable, still whispering through the dark. The universe has kept a memory of its youth, and somehow, after billions of years, beings made from later stars learned how to read it. There is tenderness in that. We are latecomers to the cosmos, brief creatures, small observers. But the universe left traces old enough for us to follow. It did not explain itself in words. It did not make itself simple, but it left light. And tonight, that light has carried us farther back than any myth, any ruin, any ancient manuscript preserved within the archive. Farther back than human memory, farther back than Earth, farther back than the sun, toward the first visible page of everything. Section 13. The first visible page of everything is not a page in the ordinary sense. It cannot be turned by hand. It cannot be held beneath a lamp. It cannot be kept safely between covers. And yet, in its own way, it is one of the oldest records in the archive. Older than stone, older than earth, older than the sun, older than every star, now visible beyond the observatory window. It is a record made of light, a record that began traveling when the universe was still young enough to have no stars at all. Tonight, we have followed that light backward. We began with the mistake of imagining the beginning as an explosion in empty space. Then we slowly let that image fade. We learned to imagine something stranger. Not matter rushing into a waiting void, but space itself expanding, distance itself opening, the universe cooling as it grew. From the first furnace came particles. From particles came nuclei. From nuclei came atoms. And when atoms finally formed, the glowing fog cleared. Light escaped. The universe became transparent. That was the first light. Not the first existence, not the first moment, but the oldest light we can still observe. The earliest visible message the cosmos has left behind. It is important to make peace with that difference. There are some beginnings we can approach, and some we cannot yet enter. Science does not become weaker when it admits this. It becomes more honest. There is beauty in knowing how far the light can take us, and humility in knowing where the light ends. The first light is a boundary, a doorway, a horizon of visibility. Beyond it, the universe was so hot and dense that ordinary light could not travel freely. Before it, the story grows more hidden. After it, the story begins to become visible. We stand on this side of that ancient window, looking back as far as the universe allows. And perhaps that is enough for tonight. Not every mystery must be forced open. Some should be approached slowly. Some should be respected as distance. The archive has never been a place for pretending every question is solved. It is a place for better questions. And the first light gives us one of the best. How did everything we know grow from something so simple? How did a nearly smooth glow become a universe filled with galaxies? How did hydrogen and helium become stars? How did stars become heavier elements? How did those elements become worlds, oceans, living bodies, and eventually minds capable of wondering about the first light? These questions do not make the universe smaller. They make it more astonishing. Every answer opens another chamber. Every chamber holds another door. Outside the observatory window, the stars shine quietly. They seem still, but they are not still. They seem permanent, but they are not permanent. They seem like the oldest things, but they are not the oldest things. Behind them is an earlier glow. Behind that glow is a hotter silence, and behind that silence, perhaps, a beginning we have not yet learned how to fully read. For now, the instruments grow quiet, the amber lamps dim, the old brass rings of the observatory turn more slowly. The first light has carried us as far as it can tonight. It has shown us a universe newly transparent, a cosmos without stars, a darkness filled with the seeds of future fire. In the next chapter, those seeds will begin to burn. Gravity will gather the ancient hydrogen. Clouds will collapse, pressure will rise, and somewhere in the darkness, the first stars will open their eyes. But tonight is not that night. Tonight belongs to the glow before stars, the memory before galaxies, the first visible whisper of everything. So rest here for a moment longer. Let the thought soften. Long before any human being looked upward, long before any eye existed to receive it, the universe released its first light, and after billions of years of patient travel, that light is still arriving. Section 14. And so, seekers, tonight we have followed the universe farther back than the stars, farther back than galaxies, farther back than worlds, oceans, moons, mountains, and every familiar shape of the night. We have traveled toward the first light, not by moving faster, not by crossing space with engines, but by listening carefully to what ancient light has carried. The universe, in its earliest visible memory, was not the universe we know now. It had no constellations, no spiral galaxies, no planets circling suns, no blue world turning quietly beneath a moon. It was hotter, simpler, younger, a vast glowing fog that had not yet become transparent. Then, slowly, as space expanded and cooled, the fog cleared. Atoms formed, light escaped, and the universe opened its first great window. That light began traveling across the growing dark, across ages before stars, across billions of years still to come. It stretched as space stretched. It cooled as the universe cooled. It softened from fire into whisper. And now, even tonight, it remains. Faint, ancient everywhere. The oldest glow we can still observe. There is comfort in that thought. The beginning did not disappear completely. It left a trace, a warmth, a pattern, a memory written across the sky. And within that memory were tiny differences. Small variations, almost nothing. Yet almost nothing, given time, became more than any mind can fully hold. From those faint differences, gravity began its quiet work. Matter gathered, clouds formed, darkness deepened. And somewhere beyond tonight's horizon, the first stars waited to be born. But we do not enter their fire yet. That belongs to the next chapter. Tonight belongs to the glow before the stars. The first visible page, the ancient background, the light that reminds us that everything we know came from something older, stranger, and more delicate than imagination first allows. So let the details soften now. Let the names fall away. Expansion, plasma, atoms, microwaves, gravity. Let them drift like instruments being set gently back upon the table. You do not need to hold the whole universe in your mind. No one can. It is enough to have sat with it for a while. Enough to know that the stars were not always there. Enough to know that darkness was once preparing them. Enough to know that the oldest light in existence is still arriving. The observatory is quiet now. The lamps burn low. The fire has settled into embers. Beyond the window, the stars continue their patient drift, but behind them, older than all their shining, the first light remains. The archive will keep this page open. It will wait here in the dark as it always does. And when we return, we will follow gravity into the great clouds of hydrogen. We will enter the stellar nurseries. We will watch the first stars gather themselves from silence. And the universe, for the first time, will begin to shine from within. But for now, rest. The first light has traveled far enough tonight, and so have we. Good night, seekers. Sleep well.